My apologies this morning for the delay. I've got three screens here, and for some reason, my Mac is the only one that seems to be working, and my big separate screens are not showing what they should be showing. So hopefully you've got my introduction. As to who I am, my name is Pauline Anderson. I work as a trainer for Pearson. I have been working with Pearson since 1988, first of all as a marker, then as reviser and principal examiner and chief examiner, and now as a trainer. I still mark. I still do quite a lot of work with both international A-level and international GCSE. So today we're going to have a look, hopefully, at doing the our next. Still having some of the same problems, I think. We're going to have a look at these things. I'm going to try and give you a general introduction to international A-level physics, how the qualification is organised, how the exams are organised, a little look at doing the assessment, understanding the question types and the mark schemes, and more than anything else, looking at the support that we're going to provide for you, or we do provide for you. So it would help me if I could have some answers to the following questions. Right, how long have you been teaching the specification? Is there anybody in the group of people who actually has already been teaching the qualification and are just coming for, if you like, a top-up? Or is everybody completely new? Yeah. This is good. So there's one or two people who want to top up, but most of you are doing brand new. Okay, that's fine. That helps me to organize it. Okay, the next thing, I'm not so sure about whether you enjoy teaching Pearson Calc. I think your teaching is more to do with the students than whether it's a qualification, in my opinion. So whether or not it's whether you enjoy Pearson or anybody else, it's do you enjoy teaching, really? But what do you hope to get from me today? And that would be nice to know. And then I can hopefully tweak the presentation around it. Yeah. Right. Time frames for topics and organization. Oh, organization of a lesson is hard. Organization of a topic is better. You're relating it to real life applications. Yes. Oh, yeah. I am going to look at the marking. I apologize as well. I seem to have got a start of a cold and I'm streaming with. Okay. Oh, yes, there's scheme of work as well. Right, so we're going to have a look at each of these, I hope. Yeah. Right, let's have a look at some of the next of these. Okay. Teaching A-level. I don't know why it went to this one. Okay, Pearson is a company that I was astonished to find this, that it actually marks over 10 million exam papers in the UK alone. And then we operate in about 70 countries worldwide, and we do try as much as we can to support our teachers. As a trainer, I am very lucky to get to go and visit various people. I'm not long back from seeing some colleagues in Bangladesh, and about next week I'm going to Madrid and then Cyprus and then the Middle East. So I do enjoy my job, but we do try and actually support our teachers as much as we can. So when I get to it, I'll show you where you can download past training as well. Okay, let's have a look at our specification overload, or the whole thing. This specification has been running since, well, I think the first exam was January 2018. So there's very little difference with what the specification says. So if you notice on the screen, we've actually still got sample assessment materials. They are still as valuable, but however, actually I'll tell you, they are often more valuable because the students don't look at them. Students can access our past papers on the website as well as you can, except for the last year. So our specification is quite a long document. I actually told off some of the people in Bangladesh because they hadn't read it for the last year and so on, and they hadn't looked at the appendices, which are also extremely helpful and extremely useful. So what have we got? We have got a specification which, if you like, is in two halves. The first one is the advanced subsidiary, AS, and then we have the AL. Now, if your students want to, and they do the advanced subsidiary, they can actually just end at that point. However, if they carry on and do the next 3 units, they will get the advanced A level. The content is designed to run through from a GCSE or IGCSE in physics. So some of the things we will build on some of the ideas. If you're used to IGCSE from Pearson, you will know that we have things like the Suvat equations, and we talk about vectors, but we don't do any resolution of vectors, which we will do in IS. Similarly, with the cosmology section, it's in IGCSE, but we go a little bit further in IAL. There are 3 exam papers for each of these. So there are 2 theory papers and there is 1 practical paper. So unlike Cambridge, which has a practical examination, that we don't have a practical examination, but we do test those practical skills in a separate exam paper. In advanced A level, we have another set of 3 papers, again, 2 theory and 1 practical. We try as much as possible to develop the knowledge of the students and would then extend it into everyday things. Now, the biggest problem that most students find is that they think physics is just a body of knowledge and they're not sure about how to apply it into other areas. And it's that application, which is actually 40%, a little bit more than 40% of this exam, which is why they say, oh, physics is hard. Physics is not particularly hard, right? When you read the specification, we have got what we call compulsory content, right? So all the items have got to be taught. The word including specifies the detail of what we have to cover, right? We have 16 practicals throughout as well, which give you, again, a breadth of material that you should be covering and looking at. Excuse me, I'll go through these in a bit more detail. The depth is as specified in the qualification. Don't try and overteach. I'm just going to, excuse me, I'm just going to close my audio for a moment if I can get it back. onto my first screen. If not, I apologize. I'm going to need to cough. Right. So this is an example of what is in the specification. This one is from the first unit in AS. And you can have a look, and it's just giving you, be able to use the equation density equals rho equals m over v. Now, we've been teaching this since probably year 7 or maybe year 8, year 9. There certainly has been pre-GCSE and in IGCSE, and now we've got it again. So it's not one that we need necessarily to teach again, right? We may want to teach some of the practical skills involved in making this a in finding the density of an object, but it's something that can come up in their exams, right? So this is a topic that we won't necessarily, someone just said they want to look at how are we going to make time for everything. Well, you don't need to sit down and say, oh, I need to do half an hour on density, because they've done density, right? What they might need to spend more time on is knowing about the upthrust. Upthrust as a force will have been mentioned at IGCSE, but not the fact that it's equal to the weight of the fluid displaced. And then you take those items and you take them into Stokes' law, right? And then you've got, understand that this equation applies to small spherical objects, right? So again, you're not going to irregularly shaped objects, and you're not going to large objects. So the depth of the qualification is specified here. Similarly, it tells you that Stokes' law is going to be applied for laminar flow or not turbulent flow. So when I'm looking at planning my work, I know that I don't need to talk very much about density, but I do need to talk about laminar flow because it's something that's probably new to them. Oh, and certainly turbulent flow. And then we have got, do they need to be able to derive Stokes' law? No. Be able to use. Be able to use means, can they put dimensionally correct quantities into the equation? Can they rearrange that equation? Now, I've been persuading people for years not to teach triangles for to IGCSE. And the Stokes' law is a reason, because you've got 1, 2, 3, 4, 5 quantities on one side and only one on the other. How does that fit into a triangle? It doesn't. Is there a document which mentions what has been covered up to IGCSE as you're only teaching A level? Not as such. I don't think so. However, you can download the international A levels, international IGCSE specification as well. There's nothing to stop you having a look at that. On the IGCSE website, there is also a mapping document which tells you what it covers compared to the other international exam papers like AQA and Cambridge. I think IGCSE is going to be pretty standard. I mean, things like density is there, right? So the core practical, I will show you later, and it's actually on one of the documents that Hansel has actually put into the resources for you. There are various ways of teaching this. There's a document. It was, when I gave it to him, it was a spreadsheet, which actually has a short video link for every single core practical, which is useful. Hooke's law was in IGCSE. The idea of stress and strain and Young's modulus wasn't. So if you're totally new to this and you haven't taught IGCSE, it might be worth your while just going through with a copy of the document of the specification and highlighting what was done at IGCSE. So in each of these cases, when you're looking at it, the practical is outlined. You've got be able to understand, be able to calculate, right? And they're giving you further information like estimation of area and hence energy change for both linear and non-linear graphs is expected. Well, I should have been clicking at this. Apparently, they're giving me where my core in practical investigations are. Right, and this is back to the overview of what I said. There are 3 externally examined units in advanced subsidiary, and these are units 1, 2, and 3. 1 and 2 are a theory. 3 is a practical paper. Will you notice that minimum of 40% of advanced AS and advanced AL, international AS and international AL is 40% maths, right? So maths is something that you should address, and maths is something you should talk to your maths department about as well, because it can mean the difference between success in teaching a topic and failure is if they haven't got the necessary math skills in advance, and you're assuming they have, you end up going round in a circular manner trying to find out what they've done. In the in the AL, you have got extra units 4, 5, and 6. Again, 2 theory and 1 which is practical. So what are they? The first of these units is mechanics and materials, and it's in 2 sections, and you do not have to teach it in order. If you wish to teach it and do the materials first and then do the mechanics, or if you wish to even leave it and do waves and electricity first, then you can do so. We're not requiring you to teach in any specific order. What we are requiring you to do is to do these 3 exams. We offer the qualification in October. We offer the October, November. We offer the qualification in January, and we offer it again in June. So if you wish to, right, depending on when your year starts, your year could, for example, start in January. So by June, you might want to do maybe unit 1 and maybe unit 3, leaving unit 2 to be taken in the October. Or you could have all 3 units taken at the in the following January. You have a lot of flexibility and a lot of freedom on this. However, notice unit 1 is 40% of the advanced subsidiary, 20% of the international A level. Right? So is unit 2, and unit 3 is 10% of the total A level, or 20% of the advanced subsidiary, right? And all of these papers will probably include short open response. By open response, we mean we're not giving them specific answers. They have to dig it out of their memory, or they have to work it out for themselves. Whereas a multiple choice is often called a closed response because we give them the options and they have to pick the right one. We will have calculations. Calculations can occur in the multiple choice as well. We will have extended writing as well. In the practical paper, you will not get multiple choice, but you will get everything else. You will get open response, you'll get calculations, you'll get short responses and some extended responses. When you go on to the second year course, if you want to call it that, again, we're not requiring to. If you really want to, you could teach Unit 1 followed by Unit 4, if you want to. Not that I would necessarily recommend it, but you could do it if you wanted to. There's no requirement. We're not going to tick the book, and so on. So they've got further mechanics, we've got fluids, we've got particles. Unit 5 is thermodynamics, radiation, oscillations, cosmology. In some cases, it's actually useful to do the oscillations before you do particles and mix those two units up. But we wanted to keep the total amount of content the same in each. But that doesn't stop you from teaching it in whatever order you wanted to. So in Unit 6, again, a similar paper to Unit 3. However, there is one skill in there that is absolutely new, and that is using log or log graphs. So that's a skill that you need to teach. Right, now, I want you to have a look at your, you should have got in the materials, you should have got the specification. Okay, so have a look at this particular question on the screen. All right, and what I'd like you to do is to think about, where has this come from? Which part of the specification has it come from? What has been assessed here? And have a quick look through your specification. Okay. I'm going to try and read some of these. Excuse me, I'm ever so sorry about my chesty cough at the moment. They need to know about finding slope or tangent for instantaneous velocity. Yes. Yes, that's very definitely. It's one of the things which was on the screen. I'm fairly certain it's in the specification. Yes, it is a skill that they need to know. But is it something that you need to teach, or is it something that you need to have talked about with your maths department? Probably need to talk to your maths department. So please have a look, see if you can identify where this is. I'm going to give you a few minutes. Yes, indeed. Any particular specification point? You've got the right units. Right, I think this one is, I think it's specification point 30. So it is be able to, Be able to draw and interpret stress strain graphs and understand the term breaking point. So we have quite a lot of information on this. This is what I would call a typical application-led question. So we're not going to give them a textbook. If the answer could be found in a textbook, it would be what we call as assessment objective 1, which is recall and knowledge of physics. So this one is an application, so it's completely new to them. They'd never have thought of using Kevlar and nylon and comparing it to steel, right? So it is an application. It's probably what we call AO2A, because we're looking at advantages. So we've got them to interpret that graph and have a look at it, right? The only way of getting them good at this is to keep giving them examples, make them do more of it. Okay, so excuse me. This is one total screen. Now, if you've got your own laboratory, you've got your own room, this is sometimes a useful thing to actually put down as a poster on the side of the room, so that your students know where they're going. Units 1, 2, and 3 count for 50% of the overall exam, and officially, the content is not harder in AL. It's just more. Right? You will find that some students will do extremely well, for example, on Unit 5, because they happen to like doing nuclear decay, and they happen to like doing the astrophysics and the cosmology. And some of them are really interested in doing electric circuits. So you'll notice that electric circuits comes in Unit 2, but you've also got magnetic fields, electric fields as well in Unit 4. So what they thought of as electromagnetism and induction comes up in topic 4. So I recommend that actually having this as a poster that the kids can see what they're doing. Okay, now this is what I'm supposed to do with you. I want you to have a look at a part of a topic from the physics specification, plan the order in which you would teach the topic. Yes and no. Okay, what I would like you to do, rather than do this, is you have got a document which gives you the links to the specification of the support material. On that document, you should find links to the scheme of work and the course planner, right? What I'd like you to do is to download those if you haven't done so already. I'm going to give you some time to do that, and then I'd like you to pick, shall we all pick the same topic? Which one is more problematical, right? I'll have a read through the course, the planning documents on the scheme of work. I'm just trying to think. It's so easy to just go straight into the mechanics, or the materials, but why not go back and do? Anyone have a favorite topic that they would like to actually think about the planning for? Nobody has got any answers here. Oh, we've got projectile motion. Oh, projectile motion is really tedious, isn't it? Well, okay, you've got some people want projectiles, some people want the the models and so on in the optics mechanics. Okay, yeah, people talking about, right, so there's people seem to be split into two groups. So have a look at the specification between them on the mechanics and see if you think the order is right. I mean, it's not the order I teach it in myself. But I think most of the rest of it is pretty good. So download the scheme of work if you haven't already done it. Have a look at that and let's make some comments. Okay. Good start from basic mechanics. Right, I am going to stop. I'm going to end the show. And hopefully, I'm not sure what you can see of my screen. But I want you to have a, oh goodness, the document. You should have, right. It's on this page. I've got AL links to support materials. So you find the guides, right? And I want you to have a look at either the course planner or the scheme of work. There's a scheme of work in this list. Or did I have it in that one? So if you can find this course planner and the scheme of work though, that would be very helpful on that page. Right, I'm going to give you about 10 minutes and then we'll have a look. I will do the same on mine screen and see what I feel as useful as well. Yep. Okay. I'm not sure if my audio is off at all. It just might be that I was a bit quiet at the moment. So I have downloaded the scheme of work, as some of you could see, and I'm just having a look at the mechanics section. And the scheme of work is quite useful. Somebody was saying earlier that they hadn't actually taught the IGCSE, so you will notice here that there is this section. Now, this is meant to be 3 weeks. And to me, that feels too long. Um, maybe a week on this section, mostly because the maths may not be very good. When I've marked in IGCSE, the problem is that they don't know what to do with the squares. Same problem when they get to the kinetic energy equation as well. They have problems with that one. Let's have a look through the rest of this. Why are you not letting me? Apologies, as soon as I forgot, this is not as useful in some. I'm looking at all of this, and this is all. I mean, if I were going into an A level, and I'm really keen, I'm starting my A levels, and they're actually meeting most of these equations that they've done before. They will have met these. They'll have met all of this. Equation 9 seems to be the first week where they've actually got something totally new, which to my mind seems a long way into the course. Although some students will appreciate the time to settle in because A level is a big demand. So if you are going to stick to that, then it might be an idea to do the questions rather than do the teaching. Again, the falling ball method might maybe start that. Have a look at the materials, the Hooke's law. Um, I think this is. I mean, they've given you 28 weeks there. Mm. And then the A2 units. I think there's an awful lot of material that's possible there, and they've given you. I prefer the way they've gone through the A2 units rather than the A1 units. I would have probably taught the A1 units in reverse order. I would have probably taught I would have probably started from the reflection and refraction, maybe then go back and do the oscilloscope and so on. Is there anybody else who agrees with me? Mm. There's some interesting comments there. Um, yeah, the fact that it might be 2 years since they started, so the school does tend to teach. The advantage of using a scheme of work is that you have got everybody knows where they should be, right? Let's minimize that. Let's have a look at this one. Everyone knows that if it's week, for example, week 18, they should be having a good diffraction. And that's helpful in many senses if you have more than one I, IAL class. However, if you're stuck with equipment and you haven't got lots of, for example, ripple tags or lasers to do diffraction, etc., then having everybody wanting to do the core practical as core at the same time can be very demanding on the technicians. I think I was just looking at the course planner, and I think the course planner in some ways is a little easier because you've got the same number of weeks. You can do this to match your school. And they're giving you the rough idea of where they want you to have. So they've got 3 weeks of materials compared to 10 weeks of mechanics, compared to however many that is, 7 or 8 weeks of the waves and particles, and the remaining 7 weeks for current electricity. But it might be helpful to sort of think about this and say, right, by the end of week 10, we will get to the same point, and then give the individual teachers a bit more freedom and a bit more flexibility to actually work within that framework. It would also mean that possibly that somebody might want to start with the unit on materials first and do 3 weeks of that, followed by 10 weeks of the mechanics. And then again, that means that you're offsetting the demand for the equipment in your laboratory. And that can be a real demand because the equipment can be very expensive. So this is something that you either as an individual teacher in your school or one of a cohort of physics teachers needs to sit down and think about. I will say, as an examiner, as somebody who writes exam papers, I don't use the textbook. I do not use the scheme of work. The only thing I ever use is the specification. And I don't go from the spec anything else. The specification is the only thing I test. So I'm saying it now as somebody who marks A level and so on, and go around and I speak to people and they say, well, oh, you didn't ask this question in the textbook. To be honest, the textbook is something I really don't use. And I don't test it. I'm not prepared. You can use any textbook you wish. I know this is a Pearson course, and I know that we have a Pearson textbook, but if you are new to Pearson and you don't want to buy new textbooks, you can use any textbook. Stokes Law is Stokes Law, whether it's in the Pearson textbook or whether it's in the Oxford and Cambridge textbook, or whether it's in a home GCSE, a home A-level textbook, it's the same thing. So I wouldn't necessarily feel that you have to follow that scheme of work. As you can see, I mean, it's, I've been talking about doing 1, 2, 3, 1, 2, 3, 4, which is almost the same as they've done, admittedly 2 years ago, but they've not long done their examinates. They will have had to do some revision as well. Is it recommended? I can't make that recommendation for you, Anton. All I can say is, as I repeat again, the person writing the exam paper, right, is not going to use the textbook. The only thing they are going to use is the scheme of work, right? So if you have a textbook that you've been using and you know inside and out, there is no requirement that you change to the Pearson textbook. You might find that you were happy with one of the others. You might want to go back to a really old-fashioned textbook, or you may want to use your own material, your own teaching material. Any other resources we can use apart from the textbook? But please, by all means. Now, I did let me see, I did give you, I don't know where I put that link on here, right? Sorry, no, it's not that one, my apologies. It was on this one. I've given you a few links to some places, but particularly for practical. But down here, there is a company called Physics Online. They do enormous numbers of YouTube short videos, mostly short videos. Some of their content is paid for, most of it is free. You've got Physics Maths Tutor, again, has got a really good selection of things. And I went looking for somebody, and I found Guerrilla Physics, and some of that material is also useful. So by all means, use any textbook you choose, any means you choose. So if we were talking about the mechanics and we were talking about the, let's see if that one would come up. There is this particular company that does a lot of the practicals. Some of them are A-level, some of them are IGCSE, some of them are below. so that, for example, they've been very kind in giving me some of the access to some of this, but this is a paid for resource. You might think it's expensive, but it's £100 per school per year for access for every single student and every single teacher in science. So including the biology, including the physics, and the chemistry as well. And it does cover an awful lot of the content. You might have to root and toot. I would like to know if a recording is to be given to all the participants. Yes, you can. But it doesn't appear immediately. You get the recording at some point later, and I think it will also go onto the website because all of our past recordings have gone onto the website as well. Right, so I'm going to attempt to get back to my PowerPoint if I can. I'm going to play from my current slide and have a look and see if I can carry on. So we've spent a little bit of time looking at the specification, looking at the order in which you teach it. And I'll say again, it is not prescriptive. We do not insist that you teach in a certain order. In my opinion, the course planner was always more useful because it gave me an opportunity. It said, well, 10 weeks for this, 4 weeks for that, 3 weeks for that. Think about your own school. If you are, for example, in a Muslim school and it's coming up to Ramadan, is it a good idea to teach a really difficult topic at that point? Because your students will not necessarily be at their best at 2 o'clock in the afternoon because they haven't eaten since before dawn. You know, think about it. Think about your school, and work out what fits best for you. And I think the overall course planner is useful, and then go to the scheme of work. Now, talking about practical guides as well. If you're planning, please integrate practical as much as you can. There is a practical teacher guide that we've included on the website. It's got information about all of the core practicals for both units, and there is a matching one for the students. The students also have a similar guide. Again, on that sheet I give you links to exactly where to find them, what it looks like on the website to find it. When I first started teaching A-level, which was an awfully long time ago, we didn't have this. However, I was very lucky to have a tutor doing my postgraduate training in teaching, which was a guy called Tom Duncan. And he said, you are going to do every single practical. And he made me do every single practical from year 7 through to year 13. And I've still got my lab book, and it's about 2 inches thick of every single standard practical that you could do. And we were very much encouraged to integrate your practical, even if it's only a short demo, we have to do it. Are you not moving? I don't know. I've had so many IT problems today. I don't know what I'm not even coming back to my other screen. Oh, it did. So let's have a look at this is when we first produced the specification after the first couple of times through. What we noticed was that from what the exam My apologies, I really am getting a mess with this. We noticed that a lot of students showed a good progression from their IGCSE or their GCSE into A level, that we could build on, and we found that things like mechanics would tend to be quite good. They found that the calculation lengths were actually quite challenging, because in IGCSE the calculations are often split into sections, and you do part A and then you do part B, whereas in IAL you ask them for part B and you're not giving them, if you like, a scaffolding in the middle to guide them through it. So they often missed out key steps, and therefore they often only got maybe 1 or 2 of the interim marks. This is in line with what we find at A-levels maths. They've got to be trained to do the intermediate maths, and they've got to be trained to not do silly things like F equals MA equals F times M equals A equal, and put all the equal signs in one long line, and so on. They've got to train them out of that sort of things. They responded to new sections almost better than they've responded to the old sections. The problem-solving nature was what again made them challenging. They do have in IGCSE, they do have questions which are set as applications. So they're used to that idea. But I think the balance is more to application in IAL, and the recall is absolutely less than the rest of it. Right. The other thing we also mentioned was the lack of precision in the language. If they said the acceleration was, I'm just trying to think of one I saw recently. It said, rather than saying the acceleration increased, they said the acceleration was more powerful. Now, that to me jars as a physicist, because powerful is not something I think of as an acceleration, but it is something which you might hear on a television. If you talk about a car and it's got a more powerful acceleration, you can understand in ordinary everyday English, or watching it on you know on a film or on the TV, that they could say the acceleration was more powerful, but it jarred. And that's what we mean about the precision of the language and the terminology, right? One of the things that we did notice was that, and we're still noticing this, that students miss the question. What they see was, oh, this is about Stokes' law. And I remember doing that question 3 weeks ago, 2 months ago, and they want to give me the same answer that they did 3 weeks ago or 2 weeks ago without actually reading what the question was. And they often are poorer at looking at applying the maths. To me, as a physicist, I apply the maths first and then look for the physics. In the application of the practical work, right, the recall of the actual practical is not necessarily tested. We're looking at the skills, right? And the keywords are, again, are things like, what is a resolution? What is the language of IAL adjusted to the needs of English as an additional language? Yes. It is. It is to a large extent. We tend to try and make the language simpler. We are trying to make sure that we actually only use one verb and we don't use subjunctive verbs and so on. But that movement has also been going on in the home A level. So what we won't penalise people, and we won't penalise students, candidates, if they misspell words, so long as the words are recognisable. And when you have a word which sort of reflection and refraction, they mash them together, and we're not sure what they mean, then we will penalise, but we won't penalise spelling mistakes. And we tend not to penalise grammar mistakes, and we don't actually require them to write in sentences. If they want to write in bullet points, or they want to write in numbered points, we're quite happy about that. What we do find is that sometimes students have been trained to copy the question out. And that's not a good idea, because that is wasting your time, right? When we talk about this thing about generic terms, about answering questions, so there was an example in, I can't remember the question this year. No, it was a question on protactinium and the decay, and there was a question about safety. And they did things like use goggles, which is a generic thing, rather than thinking about this specific event in front of them. So they're using generic things, and they need to concentrate on that specific item. There was a question on stretching an elastic band, and what are the safety precautions you need. Well, that's a case where goggles might be useful, because if they said use goggles because the elastic band could snap and hurt your eyes, that's a reasonable thing. Okay. Right, it's gone backwards. So now, examiners' reports are something that you may or may not have seen. I know that AQA do something, and I think OCR do something similar to this. When we look at an exam paper, when we produce our exam papers and put them on the website, we produce the question paper, the mark scheme, and we also produce the principal's report to the centre. These used to be quite dry documents with things like, 50% of the students could get this right, and 40% found difficulty in doing this. Again, quite helpful. But now what we've got with our examiners' reports is we've got a lot of additional feedback that we can use. Okay. So what I'd like you to have a look at, it's now about 10:13, coming up to 10:14. So I'm going to end the show again. And on the document you got, I want you to, not that one. Right, I just moved this and lost it. On the other document I sent you, I'd like you to find, and I see if you can identify these. When you go into your mark scheme, and you go in to have a look, the last 12 months of the marks of the question papers are locked. That means you can access them via your exam officer, but we can't. The students can't access them. So I've given you I've asked you to look at the first of these of the unlocked ones, which was last June 24. And we're going to see if you can download the mark scheme, download the question paper, and the examiner's reports. And can we do it for paper 1, please? Again, we were talking about mechanics. Wrong one. My apologies. I don't know where that one is. And I want you to have a look at the examiner's report in particular and see what you feel about that. Let's make it a little bit bigger. Right, so this is from paper 1. Right, I'll give you a few moments to just right, okay. I'm just reading your message. You should have on your screen, you should have a thing where you can go to more, and you should be able to get your documents, your resources from that place. Right. Okay. Right. You're looking for that, and down here, these are the ones I want you to actually have a look at. And we're going to concentrate on looking on what we can do, how we can use the examiner's report to help. Right. Have a look at this, see if you can do this. I'm going to take a short break and see if washing my eyes is going to help me to stop streaming so much. Please have a look at this. Have a look at so you really need to look. I'm not bothered about multiple choice. We'll talk about multiple choice as a second section, but look at that and look again at the question paper for that particular topic and see whether, and you see how using the examiner's report and you make some sort of comments and they've given you some examples. So I want you to look at the question paper, maybe the mark scheme, although that's not as important at this point, but look at that question, some of the questions in here, and look at the mark scheme. All right, I'm going to take a short break. If you want to take the time to go and refresh your coffee or your tea or whatever, Disha, it's in the resources I've just sent. I asked our events coordinator to actually send it. So if you go to the section where and it says more, you should be able to find it in resources. Good. Okay. So I want to have a look at using the examiner's reports, right? On this one, so starting at question 11 with paper 1 from June 24. Right, and excuse me, I'm going to go away from my screen. If you want to take a screen, so have a look through that paper, about 15 minutes worth. So I'll be back about 25 to the hour. And in the meantime, I'm going to take my audio off and my video off and see if I can maybe wash my eyes and find out what the problem is, why I'm getting so many streaming problems. Right, I'm a little early, and I'm aware that people still might want to have an opportunity to look at this in more detail. But what I'm trying to show you, I'm trying to lead you through, is some of the ways in which we can use some of the support material that Pearson provide for the A level. So the documents I'm looking at the moment are the mark scheme, the question paper, and the examiner's report from June 24, and they were available on this one, which is a document labeled IAL links to support material, and I've more or less tried to give you the link to the page and giving you a guide of what is available and so on. And I'm looking at these, paper one at the moment. And when you take that question, that first question, question 11, as I say, ignore the multiple choice. There are possibly some very good reasons for actually do the multiple choice second rather than first on the question paper. This one is it's straightforward. It's an application, and because it's an application, it's based in you can tell all calculations are going to be application, because you're never going to get this particular question in the question mark in the in the textbook. So the train moves up an inclined track. It moves through a vertical height of 25 meters. Show that the gravitational potential energy gained is about that, given the mass of the train. Now, there are some differences between IAL and IGCSE, and one of the first differences is that in IGCSE, they would just have a blank space, and they would, but the same things are true for them, so they've got the same calculation to do. They should be able to do this. This is a question that they could have had on IGCSE, and they should be able to do it. The second part is calculate the work done. It's giving you the output power, it's giving you the time. And again, they should know that power equals work divided by time. So again, they should be able to do it. So what did the examiner say? He said, it was well answered. Most candidates correctly applied the equation. A small proportion truncated their calculated answer to 410 instead of 417, rather than rounding it up. And some did not convert the answers between joules and megajoules. Many candidates did not apply conservation of energy, did not go on to score further marks. Now, how do you use this in a class, right? This particular question, as I said, it's something they should have done at IGCSE. So how do you use this in a class? One of the ways in which you could use this in a class is you could give this, it's meant to, let's get the question back, it's meant to be 5 minutes. How do you know it's meant to be 5 minutes work? It's meant to be 5 minutes work because it told you 2 marks there and 3 marks were there. So if you, as your students come in, if this is on the board, if they are seeing this on the screen and they can look at this, make them work on something what I would call a mini whiteboard. A mini whiteboard is about that big, right? About the size of an A4. Some of them are slightly smaller. If they work on their answers on this mini whiteboard as they come in, they should be able to do this question. So get them to do it on the whiteboard, not in their books. And then when they're ready, when they've done their answers, they hold them in midair, right? And they hold them in midair, which signifies to you, the teacher of the class, if you look around, that 20%, half a class, 50%, oh, right, we're up to nearly 100% of the class has finished that question. They're holding it in midair. And then when you say, show me, they turn it round so that you can see their answers. You should then be able to go around and glance around the classroom and say, oh, right, okay, that so-and-so doesn't know that, so-and-so doesn't know that, so-and-so doesn't know that. But the vast majority of the class should be able to do this, and you should be able to find their errors. That's enabled you to do a revision exercise. It's enabled you to do, if you like, marking, because you can write this down in your own register. Who's done this, who's not done this, who has a problem. And then you can, at that point, you can identify where you need to target, who you need to target, and whether it's going to be a class activity or it's going to be a smaller revision activity for a smaller group of students. So doing this is enabling you to plan your work, which is why I was going back to saying a course planner rather than a scheme of work. Now, if you go through and have a look at the examiner's report again, what they've then done is to give you a worked example taken from a student. And they've shown how it's nicely set out in this particular case. And they've calculated the work done, and they've got the unit. And they've got an examiner's comment. It showed clear substitution, right? And they got marks for that. They gave the answer to 3 sig figs. How do we know it's meant to be to 3 sig figs? I mean, there is that information in the documents, but because they have got that number and that number and that number which okay, the 400 is arguable, but these two are certainly to 2SF. So their answer has got to be to 3SF. Okay, so there's some information in the question which actually guides them to getting the right answer or getting the marks relevant. And he's thinking about, well, why have they talked about calculate the work done by the engine against resistive forces? What is this bit? Why are they not getting this mark at this point? So we need to go back to the mark scheme. Use of energy conservation in there. All right, let's go back. Sorry, worked example. I can't see a mention of energy conservation at that point. Right? So it's okay. I'm going to answer the chat. If the raw data in the questions is to 2SF, the answer should be written to 3SF. Right, it depends. If it is a pure calculation, then the answer is fine to 2SF. When it is not fine to 2SF is when you have show that. Show that as a command here means it should be worked to 3SF. One more than. Okay. But if it's a normal calculation, it's okay. So the problem with this as I mean, this is useful. This is useful. You could give that example again to your students and say, this is the mark scheme. Tell me how many marks they should get. So as an example of how to use this in the document, you could do that. It's very useful for the kids to realize that there's 3 marks there and they haven't actually worked to 3 marks, they've worked to 2. And then you get questions on like question 12, right? And again, now here on question 12, it is a calculate. So, and they've given this data to 3SF, so work to 3SF. If they've given it to 4SF, you work to 4SF because it's a pure calculate. right? So we're going to have a look at some of the questions on these. In a sense, this is retroactive, but it's telling you you can use it still with this year, but it is telling you what happened to last year's students or the year before students, but you can still use it with this one. And you can use it to identify problems or areas that you should consider for your own students. Right, and there is a way of doing it for others as well, and we'll look at that a little bit later. So I'm going back to the PowerPoint. Okay. Okay. So I'm just reminding you, you've got a get started guide, you've got a scheme of work, you've got a course planner. All of these you can use, and the examiner's reports to actually sort out your work for following years. Again, a reminder of the content, the amount of information that's given in the scheme of work, which is yours to ignore or use according to what you want to do. I mean, trolleys, you might use this displacement time graph as being, again, it might be the idea that you want to teach the tangents, right? Measuring gradients. So you might use this as the means of teaching tangents. They should know these equations, right? Are there things that you might want to do when you plan your lesson? This is really quite an interesting one. So, when you plan your lesson, do you plan in sort of 5-minute blocks, or do you just give, oh, I'm going to talk about gradients, I'm going to talk about isotopes, I'm going to talk about, and yet almost wing it, what my husband used to call door handle preparation. And so he, you know, as you make the preparation in your head as you go into the door. Or is your school one where, you know, it should be at minute 20 of this lesson, you should be doing this, right? Thinking about what you've been doing already. Are there things that you've got to do for this specification to change your planning, change what you do, change how you teach? Now, as I go through, I want you to, I'm not going to give you any time necessarily at the moment to actually think about this. What I want you to actually do is hold it in mind as we go through the next section, right? So as we go through the next section, are there any ways you might need to adapt your methods of teaching or your methods of lesson planning to deliver this specification? Right? Because what I'm going to come and do and have a think about now is, what does the examiner think about? The examiner, first of all, thinks about these assessment objectives. They are in the specification, and they are probably something that you've flicked past and not even considered. But in actual fact, when I'm writing an exam paper, this is what I look at first. I look at all of these first. They are the same ones as in IGCSE, but the second one has been split up. So this one is the same. In IGCSE, this is 40%. This is, if you like, recall. Could it be in a textbook? Right? Do I know the construction of such and such? Do I know what happens to, you know, what happens in beta decay? Do I know what a photon is? This is demonstrate knowledge, right? So it's recall. IGCSE, it was 40%. Look at the amount now, right? So in the, if you like, year 13, or second year of the course, it's down to about 30%. It's a little bit about 35%. So it's less than it was at A level at GCSE. What has now happened is that assessment objective 2 has been split into 2 sections. This one, AO1, stays the same all the way through. But AO2, which is analysis, evaluation, making judgments. If you have to make a judgment of any description, it's going to be AO2B, and it is a more difficult skill. But in the second year, it has increased. I'm just trying to read. I'm going to lead forward and try and read what the chat says. My mouse will not come across to enable me to scroll back through the chat. Can I describe? You're asking me for information that is so personal. Can I recommend an effective lesson plan which will be suitable for A-level physics students? I can remember, I can advise, if you were to give me a lesson plan, if I were teaching you face to face and you were to give me a lesson plan, I can suggest improvements. But once you're in your classroom, you're in charge of that classroom. I'm putting my spin on how I teach is not necessarily going to do you any good. So should you use a separate lesson plan for each topic? I would tend to use a lesson plan for a section. And I would tend to think I'm going to do this activity. I'm going to do some calculations. I'm going to use this bit from YouTube. I'm going to use this bit from the textbook. And I would plan maybe a week in one go. I don't think I can plan more than that because my next week's planning will depend on how well this week has gone. Right, so let's go back to these assessment objectives. This is the third one. This has stayed the same. So it's still 1/5 of the entire course is practical, based on practical skills. Right, now you're not going to build a skill up. You can't go and drive a car unless you've actually had somebody next to you who's taught you how to do the acceleration, how to take bends, how to do a 3-point turn, how to do an emergency stop, how to do reverse parking. So you've built up a whole range of skills when you were driving, and you've got somebody sat there. You can't just go in a car having watched Grand Theft Auto, for example, on YouTube or on a gaming machine and go in and drive. It's not possible. You've got to learn the skills and you've got to be taught the skills. We've got the whole same thing in physics. We have got analysis skills. We've got evaluation skills. Again, it might be useful to go back and have a look at some of the IGCSE papers, and they are building them up at that point, and they are trying them to do so. They are expecting evaluation and data, and it's still 20% of IGCSE, and it's still 20% of IAS and IA2, right? I would agree with you. A gradual release of responsibility. Good idea. Yes. It still can be taught. Now, when they write an exam paper, they write to this specification and they write to this balance. And I'm going to say something else, which possibly you've never thought of, is not all marks are equal. So when somebody goes back, thinking back to that question we just looked at, question 11, right? there is an easy mark at the beginning and there's harder marks further on. not all marks are equal, because not all marks are targeted at the same grades. Some marks are targeted at grade E. Some marks are targeted at C. Some of them are targeted at A and above, right? So how does the delivery of mechanics units offer different? Oh goodness, I could write an essay on that. Thank you. No, not going to go there. The answer is, in essence, not. I don't think there should be any difference. But you could argue it either way. So when you are writing a test for your class, when you are thinking of your class planning, right, please keep these proportions in mind. So 1/3, 1/3, 1/10, and 1/5. Keep them in mind when you're doing it. Don't make your physics only about recall. Your physics should have an awful lot of this about the application unfamiliar, especially when you're writing a test at the end of for the end of topic or setting homework. Homework should, I think homework should be AO2 or AO3. You don't need, no, just keep going. Make sure your homework is right. I don't know what is, that's why. So the percentages of these assessment objectives are the same in Unit 1 and Unit 2, and obviously Unit 3 is almost entirely AO3, right? And the same, and this goes for the whole unit. Again, this is an important slide to keep in mind for when you are doing your lesson prep, and also for when you are doing, more importantly, for doing your tests, right? So let's have a look. You've seen some of our questions, but let's have a look at them. We were going to have multiple choice questions. There's a very nice video I can show you a little bit of later, which is how to answer multiple choice questions. And again, it's worthwhile showing to your students because it's training them in how to eliminate incorrect answers and so on. We have short open questions, we have calculations, and we have open response questions, and there is one extended writing. Extended writing, I will repeat again, please take the message to your students. It does not have to be in paragraphs, sentences. It can be bullet points, it can be numbered points. What we're looking for here is a sequence of ideas, the physics, the logic, the mechanism, and it's often going to be on an AO1. It's going to be a recall type question that we're going to have to ask extended writing. So practical skills do not have the multiple choice, right? So this simple, we're not doing, if anybody's ever worked with any schools in the States, the United States, their multiple choice can have negative answers. We just give you 1 mark and we ignore, if you've not got the mark, you don't get the mark, that full stop. Whereas in the States, they will give you +4, +1, -1, and -4. So you can end up with a very interesting score on that. Okay, so this is a simple type of thing. This is recall. They should know this. They should know whether it's proportionate to the velocity or the velocity squared. And they should know whether it's directly proportional or whether it's indirectly proportional. But a lot of students will go, oh, okay. And they're not realizing what structure the question is giving them. They're asking them to effectively to make 2 choices, right? So is it V or is it V squared? is it, so those two together, is it, that's your same one then, but you put these together like this, and is it V, or sorry, I should have said proportional to V or proportional to 1 over V, right? So they're looking for direct or inverse proportionality. There's ways of training your students to do well on multiple choice. I'll show you that video a bit later, or at least give you the link to it. Okay, so this is our short answer. When we have notice in we have one command. Explain how the resistance of an LDR changes with the illumination. We've then got what I would call scaffolding. Your answer should include reference to conduction electrons. Now, when I say teach students to read a question, this is partly what I mean. If it's explain, you can think of explain as state and explain. So how does the resistance of an LDR change with illumination? So they should make a pattern statement. When you increase the illumination, the resistance of the LDR, and then they should make goes up, goes down, doesn't change. They've got 3 options there. And then they should give the physics behind it, what's happening to the conduction electrons, because the conduction electrons do X, Y, and Z. So again, these are things which students will improve on with practice. This again is something that you could give as a question to settle students down as they come into the room, right? So in this case, you're testing 2 things. Do they know what happens with the LDR? Right? Do they know how to structure the question? Right. Right. And a similar one of these. Right. This one has got a little less structure, but it is there. The structure is here because they're told it's something to work function. Calculate wavelength. So the first thing they should, and then they talk about the photoelectric effect. So the first thing they should be looking at is, what equation can I use? What data have they given me? Things which they should be able to, again, pick up. The equations are always given. So at the end of Unit 1 paper, the equations that you should be able to use in Unit 1 are there given. At the end of Unit 2, they will have Unit 1 and Unit 2's equations. So the equations are always given. So this is selection of the equation. Can they do it? This one was, again, is open response. It's 4 marks. Because it's 4 marks, it's going to require 4 specific things. And when I looked at it, I thought, oh, this is quite demanding. And it is. This would have been later in the paper, and it's not targeted at students who are working at grade E or D or C. It is targeted at students who are working at a high ability. Right? So when you're looking at this, they've got to explain this area. They've got to explain this area. And they've got to explain what's going on in here. Maybe at this end, and maybe at this end. Right? So it's to do with, I mean, I would have been tempted to take my line through and have a look. Sorry, it's a very poor line that I've drawn there. But again, talking through this in class before you do it is actually quite helpful. And I've mentioned this further on when I look about what we call a walking talking exam as well. Again, this is our longer extended response. You can normally indicate because they will have an asterisk at the top there, and they will actually say, so we've given you a little section about what it's from, and discuss. Oh, such a big word. Oh, sorry, such a small word and such an important one. Discuss means quite a lot. When you look at the whole page, they've actually given you a page. Normally we assess, we give 2 lines for every single mark, right? So looking at this on the mark scheme, you can look back. Now, if it's for 4 marks, sorry, if it's for 6 marks and it's got one of these little asterisks at the front, at the beginning of the question, right, there will be 2 marks for structure. Now, its structure is not the English structure. We're talking about English as an additional language. What we're talking about is, in this case, the physics structure. Can they explain something in sequence? Right? Can they explain A become B, becomes C, becomes D, becomes E? If they've just got all the 6 indicative content items down there, they will get maximum 4. They've got to have that structure in order to do well. But it is almost textbook. Why do we have black lines on the spectrum? So it's a spectrum produced by light from the sun. Why are there black lines? This is textbook material. So this is, but I'm saying textbook, it's a standard textbook. You get that explanation not just in the Pearson, but you get them in any textbook. All right. Okay, let's now have a look at my mark schemes. My mark schemes are, again, I've looked at these. These are the ones for this summer, right? If you can't get them, then see your exam officer. Your exam officer can give you a code to help you actually access these, because if you can't get them, it means your students can't get them, and then you've got secure material that you can make your marks, you can make your exam paper from, right? So okay, the mark schemes give, now we call it the answer, but in actual fact, quite often students can give you an alternative method, and the examiner has got to be able to read that method and decide, has the student done what they should have done? And if it's not the same answer that's in the mark scheme, they can still give them all the marks, right? It will show what we think of as the indicative content. In other words, the guidance to the examiner, all right? It will also advise on common errors, on what to credit and what not to credit, right? In all of this, all of the examiners are guided by their team leader. Their team leader, there's a whole preparation scheme where they're given material to practice on, where make comments to the examiner, or the principal examiner. They're given further material to practice on, and they explain why they're right or they're wrong. Then they've got to do a qualification. So they've got to be able to prove to us that they can mark to a creditable standard. And then all the way through, the team leader is going to be dipping in and having a look at what they're doing, and if necessary, stopping them, marking for specific questions because they're not, and giving them further training. Right, so the training scheme is quite helpful. We always do need more examiners. During the summer, I had an examiner who was working from Sri Lanka, and I had another examiner who was working from Canada. In my particular team, and I know some of my colleagues had examiners from all over the place. So we are looking for examiners. At first, you might be marking some of the easier work, until you get used to our mark schemes, etc. That's always the case. So this is what our mark schemes look like, right? We show how many marks are available here at the end, 1 in the brackets, and mark 2 for that set for question 13A, right? And then we give an example. So in this case, it was V equals W over Q. Now, putting the numbers in is probably not just sufficient for showing the use of, because we want to find out what W is. So if they were to take that equation and rearrange it as W equals V times Q, that would give them the first mark, because that they have used that equation, they have rearranged it. The second mark is finding the evaluation, finding a value, which is this. Now, quite often, in this case, it's fairly straightforward. But if we have got a calculation where we're using G, and somebody, for whatever reason, decides to use the IGCSE value, which is 10, rather than the 9.8, or some of them want to use 9.81, we will get slightly different values in our evaluation, right? So we sometimes give a range. Okay, we sometimes give a range of these. If we have a calculation where the answer to one section is required in here, for example, if we look at 13BI, we're finding a time, and we find the time is 0.45 seconds, but you will be using that time again, possibly as speed is distance of time, and using that same time. If they'd made a mistake here, or if they'd incorrectly rounded it, I mean, we talk about significant figures, if they decided to round it to 0.5, the examiner would have to take this and carry that error forward and work through their calculation using 5 rather than 4.5, right? So if I make that a little bit clearer, so we've got 4.5 there, and we've got 4.5 there. If they had rounded it and they'd used 0.5, we would still, as an examiner, have to check it. So we're not going to penalise them twice for the same rounding error, right? If they had given it to 5 places of decimals, we don't like it. Now, it's good practice to put the units in as you go along, but many students don't like doing so. But please make sure that the units are in at the end. Make sure the units are at the end. Make sure that you've got, notice that they've got ECF, error carry forward, right? Make sure that they're using the units all the way through, if you can, please. It's good practice. But I do know a number of students don't like putting units into the end. Okay. Right, this is our indicative content question. Again, you notice it's got a star. It's not always at the end, right? So I'm not sure which one question this one appears for, but it shows a coherent, we're trying to show coherent, logically structured answer, right? Not spelling, not punctuation, not grammar, structure, right? Physics structure. So we give 6 points, 1, 2, 3, 4, 5, 6. 6 points that we expect to see for that question. And we would expect them to be more or less in that order. Sometimes you can, I mean, looking at this one, temperature is higher, there is more conduction, free electrons. Your students could have written these two in the opposite direction. They could have said, when the temperature is higher, there is a lower resistance in the thermistor because there are more conduction electrons. And that would still give me a logical structure because they're linking it with things, words like because, thus, so that, therefore, or is caused by, it causes. And they're giving us that causality, the linkages. So if they give 4 of these in any, all 6 of these in any random order, they would still get 4 marks. If it's in a good order, they will add extra 2 marks in. If there's some hiccups in the order, then they might just get 1, right? So the indicative points are added to, as you can see on that table. Students go, oh, I don't know how to do these, but they're actually, again, it's something that you can train for. Right, we try and apply the mark scheme positively. We reward them for what they can do rather than what they can't do. We don't penalise, except if it's contradictory. All the mark schemes, all the marks are available, and I have had students in the past who have got all of the marks. I'm trying to think. I think about 3 of my students managed to get full marks. Most of them make a silly mistake somewhere or other, and it doesn't detract from the quality, right? If the answer matches the mark scheme, they get a mark, right? The examiners are always told to contact the team leader. If somebody crosses out work on their exam paper and they don't replace it, we will mark it, right? If it's been crossed out and replaced, we just ignore what's been replaced. We ignore what's been crossed out. Okay. Right. So if we have a look at this particular question, right, what I'm saying, our exam writers, principal examiners, work to the assessment objectives. So looking at this specific question, this is a skill you need to do because it's something that you should make sure your question papers are balanced and they match ours. Don't just test recall. So a student carried out an experiment to determine resistivity. She made those measurements. Determine, right? This is such a key word. Determine, right? Right. It's a word which says you're probably going to have to do a calculation. I've got 3 marks here, right? So, so you're going to have to do this calculation. So you're going to have to find the resistivity equation, right? And put those numbers in. So you use the equation, rearrange it. Then you've got to find what the answer is for this particular data. And then you've got to take a further step because it says determine the metal of the wire. So you've got to say it is aluminium because the resistivity that is matching, or it is not tungsten. So that's this skill. You have to make a judgment. Weaker students tend to find the resistivity. They use the right equation, they get the value, and they don't take that further step because in their head, it is, well, it's obvious, but they need to say that logical, obvious statement. Because the resistivity of this metal is such, it is probably going to be, and so on. Is there a document for alternative answers in A-level like we have in GCSE? No, there isn't. Again, it's something that I find. I mark the A-level in January usually. It's the part of the year that I'm not as busy at, because I also mark for Cambridge and I mark BTEC and some of the other courses, and that's. And actually, yes, it's one of the things I find it harder to do. But their answer is that the two bits of the mark scheme, the bit at the beginning is the mark scheme, and their example is actually separately. So when I mark myself, I take that document and I turn it into mark scheme example, mark scheme example. And if I find a new example, I put it into my mark scheme. So yeah. Yes, I would agree with you. I find A level harder to mark, but it is a harder subject. So yeah. Okay. How would you encourage a student to develop confidence in tackling questions such as this one? Because the context is very different from where the concept was initially learned. So I don't know, I'm just looking at my time on this. Yeah, that's what it says. You can teach the qualification on, you can go on to Gateway. If you've been teaching it for a little while, you can. They're not as fussy with the IGCSE. They want you to have taught physics for a little while, but they're not necessarily fussy that you teach their specific qualification. I would find it very difficult to teach. I do find it very, it's more difficult to teach IAL without, sorry, it's more difficult to examine IAL, be an examiner, if you haven't taught it. Right, so back to what this is, encouraging students. I would always, this is, we're back to Kevlar again, aren't we? I would always, when I'm looking at this, is to say to the students, go in with a highlight pen. In the past, I've taught some students who are hesitant to use a highlight pen on the exam. And I think it's quite important that they do mark it in some way. I mean, I've been using this specific color, and because I wanted it to be definite, but if I were being a more hesitant person, I might go in and use I might use a softer color, right? In this case, I've got one where, I quite like that. It's disappearing as I do it. You can actually get that with a highlight. You can a highlight pen where you can erase it. So you can get highlight pens in very soft colors. So you've got somebody who finds them quite in their face, you know, that virulent green and the bright yellow that occurs and the red that you can't see through. So encourage your students to, oh yeah, we will get to the practical assessment as well. Don't worry. I will get to the practical assessment. So in this one, this information at the beginning here is setting the context, right? So, and this is your diagram, so they can see a communication cable connected to a machine on the side. So they're marking the cable, and there's the a machine or to a ship on the surface. So, right. So, and they then give you a bit more, what I would call scaffolding. So they're telling you a bit more. It's got to withstand large pressure and yet be light. Okay. So they're giving you guidance in the question before you get there. So they're giving you the densities, right? And then you've got to say whether it is more suitable to use in the outer casing, right? Now this one I know is following on from a previous thing. So at this point, this deduce means they've got to start thinking about it. How are they going to do it? Is this going to require a calculation? Quite probably. Why is it going to require a calculation? It's going to require a calculation because they're giving me data. Okay, so which calculation can I do? Which of these equations that they've given me is going to talk about? It's going to talk about, now the density is straightforward. I can talk about the density because it says large pressures be light enough. So the density is low, so you would almost go there. Will it withstand the pressure? Right? So you've got to talk about the pressure. Can you see you can actually train your students and give them confidence. I honestly feel that doing worked examples in class or actually in the classroom is something that's going to help, right? And giving them, or even, dare I say it, putting them in groups of 2 or 3 and saying, okay, this is a question. How will you start this question? What are you going to do? And get that group of 3 people with this question, and another group of 3 people with a different question, and another group of 3 people with a different question. And then they can actually present their methodology to the class, either as a little presentation, as a PowerPoint, as a poster, or whatever. There is something that they can do that they can enable them to actually work on this. Right. Again, this is another way, another resource that you can use with your students. All right, and this is specifically, and we're talking about practical work, this one is for Unit 3. Okay, we have got exemplars for Unit 3 and Unit 6. And we've got the exemplar response and we've got the examiner's comments. Okay, so describe what the student could do to obtain the data to plot the force extension graph. Right. Measure the mass of the load using a balance. Repeat for the same mass. Multiply with gravitational acceleration to get F. Use a meter rule and a set square. To place the meter rule parallel to the spring and measure the initial hang loads on and a varying mass and measure the final length, subtract initial length, and so on. So it's got the first marking point is clear in the first, so that's giving you how to measure force, right? So they've got to know how to measure force, how to measure an extension, right? There's a clear reference to the calculation of the extension by subtracting the initial from the final. Although it doesn't refer to parallax, it's credit worthy of getting the third marking point about using the set square and ensuring the ruler is parallel to the spring. Okay, many students didn't give that mark because they didn't bother about the accuracy and so on. And the final marking point is rewarded responses that explain how the parts, what you do, repeat measurements corresponding and looking at, right, and the plotting a graph, right. Hang loads of varying masses enough for the marking point. So we have, right, and let's have a look at this. So you've got this one for our practical units, these exemplar. We've got this practical guide, right? It's quite long, this practical guide. And we are aware that sometimes our students need a practical guide. So there is a student version of the practical guide, which isn't as long. This does go through different activities. It is very, very useful. I mean, if somebody said to me, can I have the practical guide or can I have the textbook? I'd have the guide. I wouldn't have the textbook because I can Google the textbook. I can look at I can look on the internet and I can find what I'm doing on the internet. But the practical guide, it not only tells you how to do the practicals, it also gives you guidance on what sort of questions to ask your students as they're doing the work. And it gives examples of how it's integrated into the exam paper. I'm also going to mention there's one of the appendices, I think it's 10, which does all this thing about the combining inaccuracies and so on. Right. So these are the things that it's got in the guide: the assessment, core practicals, the mapping into maths, teaching approaches, answers to the student guide questions, and answers to core practical questions. There's a lot in there, and it's free for download. Right. Now, this is, I talked about that my tutor when I did my initial teacher training was Tom Duncan. Incidentally, he wrote at the time very, very credit-worthy textbooks. Some of you may still find them by Tom Duncan. He made me keep a practical book, and like my practical lab book. I think that if we're teaching skills to students, we should actually make sure it's not a case of, oh, I'm doing their practical and then I'm going off and I'm not doing anything. We should make them record it. I recorded my A-level, and I recorded, I had a lab book with alternate pages of graph paper and lined, graph paper and lined, graph paper and lined, graph paper and lined. But I think we've got, you know, it's up to you whether you use a lab book. It's making sure that they add notes. It's not just writing down a method. It's things like, how do I make sure, back to that previous question, using a set square. I had to use a set square so that I could reduce parallax errors, so that I knew that my ruler was perpendicular to the bench, etc. Apologies. It could be useful keeping it as a lab book. If you work on plain paper, then going into the into a folder, so long as it's dated and headed. Most 16-year-olds, 17-year-olds forget to put their name, the heading, and the date on, and they just scribble it down on a piece of paper, right? You could integrate it into the main folder, whatever you think is appropriate. Is important, and it becomes a revision aid, right? I'm just trying to go back and read this. Oh, quite a lot to read there. In the mark scheme, the assessment steps are sometimes written as use equation, followed by solution steps, and at the end there is an example. Do students need to follow exactly the same style? No. Is it sufficient to provide the final solution? If you were to write down the answer and not you, do you know, I never came across what I call a bald answer, where they've just written down the answer, and I haven't shown method. They need to show a method, but they don't need. It doesn't need to be the same method that we've used. Student responses are treated strictly, and they must match the mark scheme exactly. That is not true, right? There is an awful lot. There are often ways of doing a question, a calculation. These are all about to do with calculations. There are often ways of doing a calculation which are different alternative methods. We will sometimes put in alternative methods in the example. Sometimes we put in the mark scheme. If they show what we require them to show, if they've answered the question, if we can follow the logic and the calculation to use appropriate data, and they're not just leaned over and copied it from their neighbour, then we will mark it and credit it, right? If I had problems as a marker, I can always escalate it to my team leader who will sort me out for that particular thing. But no, we are probably stricter than IGCSE. And part of that is that, for example, a calculation where you've got, let's say working out the velocity from a kinetic energy. In IGCSE, it might be worth 1, 2, 3, possibly 4 marks. But in IAL, it's probably only going to be worth 1. It's only going to be worth 2, maybe 3 marks. So the amount of material they've got to do in that time or in that for those marks is a higher proportion than previously. Okay. Right. They will penalize things that like inappropriate number truncation. If it's not truncated, if it's truncated, they will penalize if somebody is not using their if they do inappropriate use of the equal sign, they will penalize if there's no units. If you make a mistake halfway through your calculation, that's where they stop, right? They're never going to carry on further. So if you haven't used units all the way through, suppose it's a 4-stage calculation and you've gone wrong at the end, and you've got stage 1 correct, stage 2 correct, and then you've made a mistake into stage 3, and obviously then you can't get stage 4. So they will go back up and look at stage 1. They will go up and look at stage 2. They will then consider that this is the final part of your thing, and that's where they want to see the units, which is why I say use your units all the way through, right? So sometimes somebody will say, well, I've got to stage 2, but I've only got 1 mark. It's because their stage 2 is a number without a unit, and it's normally, so we take account of the units at the last correct stage that you've done. So yes, it can be a bit tough, but it's not tough if it's trained. I mean, I went to Bangladesh recently, and I was talking to one gentleman there who had, his students, he had 70 in his class, and in his particular class, he found that, he was getting very high marks because he insisted that they put the units in all the way through, right? So we will mark what the question asks, right? But yes, it is tighter marking than I would say for the than IGCSE. I can't make a comment about comparing it to another exam board. A is not in my remit, and B, although I do mark for Cambridge, I mark the practical paper exam, which is a very different thing as well. This is from the practical guide. This is the sort of information that you're going to get. It says it's got 3 variables to test. Good investigation. It's giving you alternative to vibration transducers. Tells you how to do it. Safety should feature, but it's got, and then it shows you how this particular investigation turns up into a practical skill, right? So in this particular example, you've got the equation, so they've got to depend on this. So you've got a practical skill, how you're going to test these, how you're going to measure these, and so on. Okay. Use of is 1 mark and so on. Yes, I'm just trying to go back and have a look at this. Do they get marks for writing the formula? No. The marking scheme is use of. So if they write the formula and they rearrange it. So again, if you remember back a few slides back when we were asked for the question wanted to know W, and they've got the equation. So if they rearranged it to show the equation was W equals V times Q, rather than the way it was written in the exam paper, that's their use of mark. Right? Use of usually means have they taken the right equation and have they rearranged it into a format they can use. Okay, let's have a look at. Why have you gone? Why are you no longer clicking through for me? Right, in that particular case, right, they've done the calculation and so on. I thought it was an example rather than, my apologies. Oh, it's a calculate. It wasn't explain how to take the data. I misread the question, as bad as the students. So the use of, if you go back to the, apologies, if you go back to this equation here, square root of mg over mu equals f times lambda, right? So they would need to rearrange that equation to give you L, right? Use of, and then do it in that manner, right? So it is hard marking, but it's just practice doing it. Right, practical skills again, identify significance, sources of uncertainty, right? And then for each of them, you would actually describe the experimental techniques. So this is the mark scheme for B1, right? So these are the possible uncertainties in the frequency, in the length, or the mass, right? And then they would actually take from each of those, maybe 2 of them, they would actually need, they would need to find these possible ways of doing it, right? In this, if the mass 0, the balance, and the reason, right? So the additional detail. So I actually think, can you get marks for writing on the, no, I've done that bit. So, okay. The exam paper itself is 80 marks. You've got, if it's 80 marks, you've got a mark a minute and a little bit extra for reading. So use the time you've got shown in brackets. Use this as a guide how much to spend on each question. The asterisk mark is, again, it should be only 6 marks. You've got the data, you've got the answers. If you've got a student who struggles and can't do the multiple choice quickly, make them do it last. Because even at the end, if they've only got 5 minutes at the end, they can always do multiple guesses rather than multiple calculation. And at worst, they've got a 1 in 4 chance of getting the marks right. But again, I'll show you something I hope useful in a moment. Right? Black ink, please. Not blue ink. And the reason that is the black ink has got some carbon in it, and the carbon is what's picked up by the scanners. Right? The information and the advice. Use a calculator. Make sure they know how to use a calculator. There's a lot of information and a lot of answers, and using a calculator. In the maths for physics teachers, and there's also some on the IGCSE, and there's some on things like Physics Online and Maths Physics Tutor, which are really good websites. Exam Wizard. Anyone used Exam Wizard? Yay, good. I've got some people who have used it. So I'm going to hopefully end that show and try and show you Exam Wizard. Where have I put it? Oh, while I mention it, this is the stuff for the students, and the maths support for the students, and practice questions and so on. So that's all there. Where have I put Exam Wizard? I had it open. Oh, apologies, on the screen. Okay. I'm just hoping. So I've gone into science. I can do find past papers. Oh, it's making me do it all over again. It doesn't need. Oh, it's gone. Right, okay. So I can go into find past papers. So this is another thing which is available, free, right? So you can go in and you can find the past papers, right? Some of this will be, and you can actually take a unit and so on. More importantly, because look at this, they've also got the chemistry and the biology and so on. So if I go into build a paper, right, I'm going to have a look at IAL. And I'm going to select physics. And I'm going to select, for example, mechanics. We've been talking about mechanics a lot. And this is important. You can, for example, select AO2. Right. And I'm not going to put a keyword in. And I can just do search. And I will now get a whole range of, again, 217 possible questions. So I can look at it and I can think, oh, that's a multiple choice. Oh, I could use that, could be quite a nice one. I've got the mark scheme and the answers to the mark scheme. I've got the examiner's, sorry, in that case, not found. But there's a formula sheet and I can think, oh, maybe I don't want multiple choice. Okay, answer question about concrete. Oh, this one looks quite nice. And it's AO2 because you're not going to find this in the textbook about concrete. You've got the mark scheme, use of, accept the ratios. Okay, and there's an example. The mark scheme is there. The examiner's report is useful at this point. And if you decide that you're happy with that question, right, you can add it to your exam paper, right? And then once you put some of these together, you can view, forces acting on a shelf. Let's just add that. Okay, so I've now got 2 questions, 17 minutes. View or add paper. If I suddenly decide I don't like it, I can then remove it. Or I can get my colleagues, I can save it, I can export it. So you have the resources in order to pick up the questions that you want to. And in doing this question this way, you notice the key factor that I did, which was when building a paper. And I picked my physics. I picked mechanics, but this was the important factor. I picked up the assessment objective, right? Yeah, if you pick that learning objective, if you pick that assessment objective, only those questions come. Any one question is not going to be totally AO3, AO2, or AO3 will be, right? Let's have a look at AO3 only, right? And this one is specifically deduce and so on. So you will get that question, conditions needed for object to be, right? You're expecting to have done all this. So any one of these, let's go back. Cancel. So if I want to select all of them, I get a much wider range of questions. The difficulty in doing that is that you end up mostly, if you're not careful, you end up being recall, only recall, rather than questions which are, I mean, here, all of them, the concrete questions appeared again. Answer questions about an experiment to determine a value for G, right? And that is more AO2, AO3 rather. So what I'm trying to say, make sure that you, when you're writing your, picking your questions, making it that you actually are using ones which are balanced and not just recall, because if you've got only recall, then you have a problem. Right, before I go back to the screen, I want to, there were a couple of other things I wanted to show you. Was it on that one? No. Yeah. On this page here, which is virtual oscilloscopes, these are useful. I mean, they really are useful. Not many schools have got enough for all people, but this A-level physics online, they do charge, but there's some of these are very useful. The daily workout book is excellent. But if you have a look at them, there are some, they will give you some free paper, free starter documents, and they've got a whole range of things on that one. I don't know the cost. This is another website which you may or may not have met. And they've got a lot of revision material here. And they've got questions by topic, questions. They've got a lot of questions. I've got a lot of materials and so on. And when I come to this one, my friend, this comes up. He's quite interesting, this guy, a physics teacher.
Gary's been pestering me a bit, telling him how to answer physics questions in exams. And this is really key examination technique. So, well, Gary, if you're going to ask the question, at least turn around and listen to me. Well, first of all, there's two types of question. There's the written question and calculation question in physics, and they're completely different. So tackle them in very different ways. Step one.
Right, and you can
it's best
see
to answer in a certain sequence. Just doesn't need to be a long essay plan. Just to maybe jot down and we'll do that, then that,
so this particular
then I'll do that, then I'll do
is
that.
about 6 minutes. I'm not going to make you listen to 6 minutes of him.
Don't kind of waffle on.
It's quite a useful thing that you can use. He's got other documents, and A-level physics online has got quite a lot of YouTubes as well. And they've got the extra support. I don't know the cost, but again, it's worthwhile looking at them. Learning check sheets. videos, workout books, etc. Right, the Institute of Physics. I've got quite a lot of practical material in there as well. Some of it is slightly old-fashioned, but it's still quite useful. I've talked about focus. Presume you know about PhET. They are, I think, getting better. They always used to be very, very American, but having said that, some of their optics is good. Some of their this one came up in Bangladesh, and I thought it was quite nice because if you have to teach the maths, then this is quite good on teaching the maths. If I can remember how to use this one. Right. So the PhET as a textbook is quite useful as well. They're the common ones. I mean, you can always go to the Khan Academy. Their work again is very helpful. On Science Emporium, you mean the on the things? No, I mean, if you're struggling for equipment, I'd go back to this one on Focus e-learning. Yeah, I'll just say that one allows you to, it doesn't just do physics, it does chemistry and biology as well. And that's probably one of the cheapest. One of the nice ways of doing this, as you can see on here, you've got properties of radiation, and they allow you to do alpha, beta, and gamma. And this one actually has got a it's got a photoelectric effect as well. It gives you a fortnight's worth of free trial if you want to have a look at it. The equipment as a thing is something that you can't always guarantee. Right, so I'm going back to the presentation. And speaking to people in different countries, they're getting the equipment. It is sometimes crucial trying to get it through customs and so on. And I would try and make links with other schools and see if you can do that. Right, okay. This is what we were mentioning earlier, looking through the whole paper, deciding what to do first. I had one student and one he was actually quite early on in my teaching career. Very laid back student. I'm not sure, and I mean he did go on to do extremely well at Cambridge in physics, and but he disliked mornings, and most of his exams were in the morning. So he came in and he wrote his physics paper backwards. He said the harder questions are at the end, so I'm going to do those first when I'm feeling fresher. And then he worked his way through to the easy questions. He did extremely well. That worked for him, but I think the idea of don't give up on a whole question. If you find one section, move on to the next bit. Right? The same strategy holds for whole questions. If you come to a question and you think, oh, I don't know what to do, I don't know where to start, move to the next question, and then you can come back. It's better that you go through and gather the marks you can for what's called low-hanging fruit. Grab that, grab that, grab that. I've got all those marks, and then I'm going to spend my time and do that quickly, right? So don't necessarily start with question 1. I quite often want to start with question 11, leave the multiple choice till later. We have something called walking, talking marks. Now, I think this is possibly more important at IGCSE level, where they may not have met the exam room before. But if your students are going to somewhere else to write the exam paper, then it's a good idea to make sure they know what to expect. You don't know the amount of anxiety that your students are going to have. Even the more able students can be very anxious about this. What I do find here is at least once, give them at least one exam paper that looks like a real one. Don't be scringy and try and get as much paper saving as you can. The exam papers are written the way they are so that, for example, new questions, they just suddenly have a blank page, and that's so that the next question is nicely set out over 2 pages. But it's useful to make sure they've seen what a real exam paper looks like. Even if the money is very tight in the school and you pass it round so they can see what a real exam paper. In this sort of walking, talking mocks, you can actually put them in the exam room with an exam paper in front of them and talk your way, just the way I've talked through some of these questions earlier. Talk them through it. Talk them through the questions, through the tiny steps, how to underline the key words, how to plan, how to remember. You might want to do it focusing on how to improve your calculations, or you might want to do it just for the practical investigation, and give them some time to write their responses in a timed manner. Okay, so I'm nearly at the end. All of this stuff is available on the website. Right. This guy here is one of 2 people. Tim Lawrence on the website is one of 2 people that you can contact if you need advice. He may not know the answer, but he will know who to ask. The other one, I'll show you his photo. So that's Tim Lawrence at teachingscience@pearson.com. This is the material. I don't know when they took this slide. This is, oh yes, past training content is there available as well. Right, so you've got AS exemplars with commentaries. You've got to get started. You've got teacher support. Oh, sorry, you've got, I don't know why that one has chemistry. I did change it. It's not appeared. Maybe I didn't save it. Apologies. It's meant to be physics, obviously. The scheme of work, it gives you recommended times, activities, it gives you objectives. I don't know if we talked about results plus. I can't access it because I'm no longer in school. You can access, and it enables you to provide an analysis of everything that your students have done over the in that last exam. And you can do it by teacher, by class, you can do it by question, and you can see, you know, this is so that you might find that Mr. X's class on this question, the mode mark was 5 out of 7. Mr. Y's, the mode mark was 3 out of 7. Why is there a difference? So it enables you to, it's particularly useful, I think, for heads of department. And you can see the scores for every question, every class. It's a free service. I can't access it because I'm no longer in a centre. Right? Maybe that should have been first. We talked about Exam Wizard. I'm sorry they give you an example there from geography. Yes, I'm just Mariam, yes, all of the resources I've mentioned are actually, I've given you a link on that page. It's IAL support links. I've given you a document. Access to scripts is available on the day of the exam release. All of the papers are available that you can actually see. Again, it's centre dependent, right? So it's something that I can't get to, but I do know, talking to teachers, they have got access to this and they can see exactly what they're doing. Because it came up to me and said, why did they only get 2 marks of this? Why did they only get 3 marks of that? In one case, it was obvious because the graph that they showed me had an axis in 15s, and we never give a mark for axis in 15s. So the student book looks like that. As I say, it is not a required textbook. You can use whichever textbook you wish that works for you. This is the other person that you can contact if you have problems and you want some answers. Jonathan Wong, who's again same email address. If you want to speak to him, this is either British Summertime or Greenwich Mean Time, right? So he's one of the people. Right. So would it be better if you provide? I can put this back up on the screen. Right, I can put this back up on the screen at the moment. Okay, it wasn't that one. It was. Right, I have provided this. This is in the resources that you can download. I can tell you what is there. And beyond that, you can actually have a look at the materials. Right, so that document and the virtual oscilloscope document I both provided today for your use. And I also provided this document, which has got, I'm going into the physics playlist, it's got about, so for every single core practical, there is a link to a YouTube or similar.
This Norwegian nerve pillow eliminates chronic pain by decompressing critical
Sorry
nerves.
about this.
Why are people with back?
Right.
So this is an experiment to measure the specific latent heat of fusion of water. What we're going to be doing is using some ice, which we're going to crush in a moment, and we're going to be melting that in a beaker full of water.
So that's one of
them. The temperature of the water beforehand. The temperature of the ice beforehand we'll know is 0.
All of them, and they do give you links to the physics online and the units and so on, but
Edexcel A-Level Physics Core Practical 16. Determine the value of an unknown mass using the resonant frequencies of known masses on a spring. You will be using this video to take readings to complete this core practice.
Okay, so you should have the ability to be able to get those 3 documents I've mentioned. You can have a look and get them, things like the course planner, the scheme of work, etc. And the PowerPoint will be available within the next, I don't actually know, within the next week, I would think. Okay, so I've now got to go back to my thing because officially I've got to I have to officially end up with that as a PowerPoint. Okay, we are a few minutes beyond midday UK time, which is fine because I started a few minutes late. I hope it was useful. Any queries, please? You've got all the resources on the website, right? Don't forget to use your own skills, your own textbook, and your own department as things again. Okay, thank you very much for your contributions. They were very valuable. They helped me certainly to help aim the presentation in different ways. And have a brilliant rest of the day.